Does a woodworker only use wood? Or can we start incorporating other mediums into our methods? Like 3D printing, for instance. Is it as easy as YouTube makers like Morley Kurt make it look? Or do you need to be an expert already in software design? Or can a dummy like me truly figure it out? Well now, thanks to Bambu Lab, we can find out. Because in this video I aim to solve 4 common workshop issues with this 3D printer. But I'll also show you how to do some of them without. Just for the purist woodworkers out there. Because I do genuinely want to find out if having a 3D printer is going to replace me making jigs and small tools with scrap wood. Or is it an unnecessary luxury? So 2 very quick thank yous before we get started. Firstly, thank you to Bambu Lab for supplying the printer. The model I'm using is the Bambu Lab X1 Carbon. If you want to check it out for yourself, there's a link down in the description. And secondly, thanks to my Patreons for supplying me with patience while I've shown them what I've been working on and asking them for advice on how to make it better. I'll be honest, a few years ago I thought there was absolutely no place for 3D printing in woodworking. And it turns out I was wrong. And that's because some of my favourite makers on YouTube like Morley Kurt and Pierre the Swedish maker have incorporated 3D printing into what they do and changed the landscape of woodworking forever. So I decided it was time for me to see for myself. And don't worry, I'm not going to do an unboxing video here, but just know Bambu Lab make this process an absolute doddle. An idiot like me went from box to boat in 2 hours. But there is one issue. Once you're fully set up, you have to pay the 3D printing tax. I'm not talking about money. This will only take a minute. Open your eyes.
Oh my goodness! I love them.
They got the reaction I wanted. Sadly, the tax wasn't paid in its entirety because with MakerWorld, a place where Bambu Lab printer users can share their designs with the world, well, you can just download any number of things to make. Like a couple more dragons. I regret nothing. Anyway, the supervisors are appeased. The real work can now begin. Integrating this amazing machine into my workflow and my woodworking. Step 1, decide what you want it to do. Entire builds, prototyping, small jigs and tools, blending 3D printing into building, all of the above. Step 2, decide if you want to download or design. Downloading from somewhere like MakerWorld is not cheating. In fact, it's perfectly fine. They've got so many different things to choose from. It's not all just dragons. But if you truly want to go from here to here, then you're going to need to design something, and that's going to take design software. And I don't want to get into the details here because I'm truly only just starting out, but I genuinely found that Shaper 3D was the easiest one to get to grips with. So now I can truly show you the solutions I found to the 4 problems that I discovered while looking around my workshop. This is fix number 1. I'm calling it the handplane star, but I'm sure there's a better name. This was my first 3D print, and honestly, I tried to come up with a non-3D print solution to this problem. You know, for the purists. But honestly, I don't think this is one of the fixes that can be done with some scrap plywood and a few bits of hardware. The issue first. I would say that 90% of woodworkers have got handplanes. And I'd say out of that 90%, probably half of them have got an older or vintage style handplane. Me, I seem to have accumulated a collection of vintage Stanley handplanes. These being just a few of them. I've got the number 4, the number 5 and the number 7. And I have one issue with all of them. This, the thrust wheel. And in a nutshell, it's fiddly to turn while handplaning. Ideally, you want to do it with one finger because when you're handplaning, that's what you have free. Having to use 2, if you can't reach to it, which I can't, means you have to come off the tote at the back, or the handle, and move it like that. And that's a bit of a faff. So I started designing a solution, and honestly, I think I got quite lucky here. You see, I wanted something that clipped over the top of the thrust wheel itself, rather than replacing it. I wanted to make use of the grooves that run parallel to the circumference, and also the grippy bits that run perpendicular to it. I started off massively over-engineering it. What you see here are all the different prototypes. Some were too big, a few were too tight, but I thought I was genuinely onto something. I admit after the 6th or 7th iteration snapped, I got a little bit cross. So I took all of the fancy stuff off it and I just made a cylinder. Just a cylinder that fits very snug on a thrust wheel. I'll be honest, it was a little bit of a Hail Mary. But now that it's on there, I can do everything that I want with one finger. I can adjust the iron out, I can adjust it back in again. so it serves its purpose perfectly. I genuinely love the simplicity of the design, and as a happy accident, if you use a shooting board a lot and you hold your hand plane on the shooting board, you can actually just use your thumb to wind out the iron or wind it back in again, depending on the level of cut you want to take. I really like that. Now I know you have questions waiting to be answered. One in particular, I'd bet. Am I doing this for money? Will these be for sale? Honestly, I think I'm really just doing these to solve problems I have. But at this stage, if you'll humour me and if you don't mind, as you're watching this video and I show you all the things that I'm experimenting with, please pop in the comments if you think anything is of a wider use, if it's something of interest to you. Because everything you're going to see solves my issues, but they might not be your issues. And I do have to add something very important here. After making this, I did some rudimentary searches on the internet to see if there was anything similar out there, see if there was a market for it. Rob Cosman has the only one similar to this that I could find. He sells a stunning hand plane adjuster called the Adjust Star for around £35, and honestly, it's beautiful. I don't think that this is a copy or a replacement. His is made from brass and replaces the thrust wheel itself, and honestly, it's a really elegant solution. This is a less elegant, far cheaper, different solution. But if you haven't heard of Rob Cosman's solution yet, check it out before you consider doing something homemade like this. As a really quick, interesting aside, 2 Stanley number 5s, 2 different size thrust wheels. Normally this would make me cross because my solution hasn't worked for everything, but it's a really quick, easy fix, just adjusting a couple of settings on my design software, printing out a couple of wheels with slightly tighter tolerances, good to go. It is something that I'd have to bear in mind though if I was ever going to sell these. So this next one is really simple. I can't for the life of me find metric setup blocks that I like. As far as I can see, the style that I like, where you can do height adjustment as well as width adjustment, are basically imperial sets that have been directly translated to metric. So instead of having increments of 1, 2, 3, 4, 5 millimeters, they've taken a 1/2 inch one and converted it to 12.7 millimeters, which is okay, but not perfectly useful for what I want. You can also get solid blocks in metric, but they don't have any gauge for height. So I made my own. Nothing fancy, just a set of blocks that are a certain thickness, like this one being 10 millimeters, and that thickness is also the height of the gap. While I was at it, I made them all slightly different lengths in case you want to use them for gauges for that purpose. And this was a bit of a trial and error kind of design. For some reason, without roundovers, they came out with bulges, and I tapered one end to make a 45-degree angle, then realized that was useless and added more bulges. So we came back to simple is better. But it also helped me discover a feature within Bambu Studio where you can select ironing, which will smooth off the surface. And that adds to the accuracy and the finish. And I'll say this as a beginner as a big plus for Bambu Lab. Bambu Studio, which is where you set up the print, so to speak, is so intuitive. The fact you can do the ironing with one click makes it incredibly simple for a beginner like me. Accuracy-wise, I found that over 150 millimeters, you lost around 0.5 millimeter of accuracy from design software to actual print. But what was important was not necessarily the accuracy, it was the fact that once I'd calibrated the design in the software to account for that, then you had consistency. So the fact is I could print 3 or 4 of the same block and have them all the same length. No fluctuations. Which when you think about it, is pretty amazing. And that it can get the calibration on these setup blocks to within 0.1 millimeters of accuracy. In truth, I probably could have tweaked it further to get that even closer, but for woodworking, I didn't think it was totally necessary. So what I did, I made a long set and I made a short set. And then I combined them into this handy desktop set. I even managed to make a block to hold them all in within a couple of minutes of designing. I made the longer ones in the hope that they would clear the throat plate and then register the height of the blade off the tabletop of a table saw itself. And then I made the smaller ones more designed for easy use with a router. So let's run a quick test with a 5mm block and see how accurate it is both on a table saw and a router by basically using it to set them up, cutting a groove on both and just seeing what depth that groove comes out to compared to the depth of the block. That's pretty close. Now, if you think to yourself over the 3 or 4 weeks that I've had this 3D printer that somehow I've become an expert in design software, managing to come up with all of these designs, you'd be wrong. It's honestly not the case. This was mainly done with trial and error. My advice would be, if you're anything like me, don't try and get it perfect the first time. For instance, with this stand where everything is held in recessed blocks, if you're worried about the tolerance that these are actually going to fit in, just print a small section like a test piece, which will take maybe 20 minutes. Try it out, adjust the settings on your software, print again and try again. Do that before you print the entire thing, which still only takes about 90 minutes. I honestly believe that Shaper 3D combined with Bambu Studio, which is the software, as I say, that tells the printer how to print what it is you've designed, combining those two together works perfectly for people like me with technological shortcomings. Now, before we get to tool 3, let's just stop for a second. If you're not planning on getting a 3D printer, and you never will, there is a way that you can get something similar to this without printing. After all, woodworking is firstly about wood. So here it is. If you can't find the setup blocks for height adjustments that you need, make your own. Sure, you can use a ruler, tape measure or adjustable square, but you could also make just a series of cuts into a piece of ply or a board that basically won't expand with seasonal changes like solid wood would. Then use that to calibrate your tools each time. After all, it doesn't have to be pretty, it just has to be effective. Now, on to tool 3. So this one has been done before, but it's in here because it's one that I can show to the non-3D people. So, mitre joints, where two 45-degree angles meet to make a right angle. And if you've done them before, you'll know these are a real pain to clamp while they're gluing up. Because you can't just put the clamps on the angle because they'll just keep slipping off. Sure, you can use a ratchet clamp, or these spring-loaded phallic-shaped clamps. Or like some people do, cut some triangular lengths of wood and then just CA glue them to where you want them to be so you can clamp. But all of those have got drawbacks, from annoyances to divots left in the wood to, well, gluing pieces of wood onto your work that you then have to knock off afterwards and clean up. But I'm going to show you the way that I would do it to avoid all of that. Just take a batten cut out of 1/2 inch plywood and then using your table saw cut a length of the triangular stock. What it needs to have is a right angle at the top and two 45-degree angles on the other corners. And then glue a chunk of it onto the batten. Bonus points if you add something grippy but not too easily compressed underneath. I've gone for sticky back foam sheets, but you could go with very high grit sandpaper, something that's just going to stop the wood marring your work while also keeping this gripped and stopping it from slipping. I thought I would use the 3D printer to improve these, and I fell down a very deep, very winding rabbit hole. My first job was to print the equivalent, and honestly I probably could have just stopped there. But, and this started to bug me, if you're doing a box or even a frame, you're going to need 8 clamps in total just to hold these onto each corner. And that's if you do 1 row of them. On a box this wide, you might have to do 2. So what I thought was, if I can combine 2 of these with a bar in the middle, then I could get away with just 1 clamp per pair. So now you only need 4 clamps, and that's better than 8. And so I set about experimenting. And honestly, though this entire process you're about to see was somewhat of a fail, it really is where the 3D printer and how you use it comes into its own. Because in a matter of minutes you can design or tweak an existing design and then you can set it off to print. And then a few hours later, it's done and you can test it. And in many ways this system worked. But I was in over-engineering mode, because when you try to put 1 clamp on these, they're pretty hard to hold together while you get that clamp into place. So, I added a sliding dovetail. So you can slide your piece in and it'll hold it there while you get your clamp into place. So now each block can take more than 1 batten. And you can adjust the length and you could print them longer if you needed to. Was it better than these? Not really. But what it did show me was what I was making was, well, overall pretty unnecessary. And so it stopped me going any further. Well, I actually did go a little bit further, and I actually did stumble on a better method, a better use, better design if you like. A design that actually means the 3D printer, in my opinion here, is earning its keep. And that's these. And it's very tricky to make these out of wood. Not impossible, just tricky. Where the triangle gives you 1 parallel edge, where a 45-degree angle meets a 45-degree angle, these can work off multiple angles because you just have to move the positioning of the clamp. You could even make them slightly different in design if you had a specific angle you work with. But if you imagine these work on a 45, and even anywhere up to probably something give or take that obtuse, whatever that is. So in all, I did waste the best part of a couple of days heading in the wrong direction with this design. But as these are 3D printed rather than made by me, I was working while they were being printed. And that, in my opinion, is a huge point to make. Once you get to grips with the design, it suddenly becomes quicker and quicker to do. You can basically spend an hour designing, then set the machine off to make a series of prototypes for you. If you're trying to calibrate something, you could even print out multiples of a certain thing with tiny incremental changes so that in one print you can see which one is going to be the perfect fit and then reproduce that going forwards. And so when it comes to a 3D printer, the fact that it is working and you don't need to be there supervising it all the time, that just frees you up to do something better. Now for the last one I'm going to show you. And this one has had the most work go into it out of any of them. This is tool number 4. So this one has cost me a fair amount of trial and error so far, but I think I'm nearly there. So here's the problem, and here is the first non-printed solution. It's all about hand planing. You see, when hand planing on a workbench, holding down your work can be really quite tricky. Fact is, you don't want clamps on top of your work, and you don't want them on the side of the work if they're going to protrude above the height of the work, because then that's going to damage your hand plane. And all in all, this can become a real pain. A vise can help a little, but a planing stop is what you really need. You see, I made this from wood, and it's in a video. And honestly, as a solution, it's fine. You see, all you need to do is screw this to the edge of your bench, or, like I've done, add some threaded inserts so that you can raise it and lower it just at a twist. As you can see though, it snapped. And I know if I'd have made it from plywood, probably never would have happened. But there's also another problem with it, and that is you can't upgrade it, you can't accessorize it, you can't make any additions or over-engineer it. And I wanted to do all of that. So this right here was my first attempt, and it was all right. It was basically a plastic adaptation of the wooden solution. But I wanted to have some form of grip on it. So Mark II came out. And so I left a recess here, a recess where I could glue some of this 2.5–3mm nitrile cork to it. I thought I was onto a winner here. I even put one of my sliding dovetails across the top here so that I could add some of those accessories I've been talking about. But here's a big tip for anybody who's starting out with designing in 3D printing. It always works better if whatever's on the bed of your 3D printer is flat. Now, because I've got the strengtheners on the back here, this had to be the bottom surface. Can you see my problem? And I laugh now, but I had no idea that this was going to cause problems, because at the click of a button in Bambu Studio, you can enable supports, which is where the software will decide anywhere that needs supporting, where there's an overhang, and it will print these little trees that will hold it in place. And it did do that. Unfortunately, the sheer amount of trees it had to print for this overhang and the dovetail made it very, very time consuming to get them off and to clean it up. I will say this before we move on to the next part. The Bambu Studio, with all of its little one-click buttons for ironing and supports, makes the user experience so much less stressful for someone who's never done it before. But I had to put my design software to use again, and I had to figure out a way of having a flat base on the bed. And this is what I came up with. I made the whole thing smaller because honestly, that was way too much. And I created a void for the rubber by printing in 2 parts. The reason I didn't just cover the whole front in nitrile rubber is because the secondary piece that I made to create that area for the rubber was going to have these 2 slots. And these were going to be to support, or are to support, thinner stock when you're planing. Let me show you. And bear in mind, this is still somewhat of a work in progress, but I think I'm getting there. And bearing in mind, from going from 1 piece to create the recess to 2 pieces, and yes, I've skinned it down, but I've also added a whole lot of bulk in it, including at the click of a button going to 4 walls rather than 2. So if you do happen to nick it with your hand plane, you're not going straight into the core. That cut 8 hours off the printing time. And so with the cork in place and my 2 gaps rather than 1 on the addition plate, because this was another failed experiment, it's time for us to give it a test and for me to show you exactly why I've done what I've done and how it works. First things first, you need a little bit of a solid area on the side of your workbench where you can put your threaded inserts in. Now I'm using these homemade star knobs, but you can actually just buy hardware that will work with the threaded inserts, up to you. I just had these left over from the wooden planing stop. In its first orientation, you can set it up so you can raise it up to around about 1 inch for the size I've made, clamp it off, and that at any stage, you can just butt a piece of wood up against it and plane away. And then in the second orientation, you just need to undo your threaded inserts, turn it over, loosely tighten it. And this is where I think I've either been clever or I've over-engineered it again. And then you've got these little right angle supports. The first one slots in the side that has got no play in it. The second one slots in the side where there is play and can be moved backwards and forwards. And when you tighten the planing stop, it locks these two down. So whatever thickness of wood you want to support, lock it up nice and tight, clamp it down, and then when you're planing it, you've got a lot of added support to hold it in place. And also if you want to have a very thin piece of wood in there, you can go down to about 3 or 4 millimeters, and you could shave off a nice thin piece as well without catching the planing stop. And in the spirit of over-engineering, I put a couple of little clips at the back. So when you're not using them, you can just hide them away at the back there, and you're probably not going to lose them. And with the tolerance, even when you flip it over to use the grippy side, they're not falling out. Do you know when you come to the end of something and what you've done is good enough, but you have an idea and it's something silly, but there's a possibility that that idea might end up being the best thing of the whole ideas, if that makes sense. I've noticed in my woodworking that often I want to chamfer all of the edges of whatever it is I'm making. For instance, if this is a table leg or a chair leg, you might want to chamfer off all of the edges. Holding it at this angle, it won't go in a vise. It's pretty tricky. So, simple, but effective. You can place your block in it. It's supported really well. You can butt it up against the planing stop, and you can make them all for different sizes. So then you're locked down and you can chamfer the edge, turn your piece, chamfer the edge, turn your piece until it's done. And one step further, you could put dogs underneath these to go into a dog hole table, or just some grippy stuff on the bottom to give you even more support. This planing stop is no way finished, but it is already better than the wooden one. And can you imagine how long it would have taken to trial and error adapt that wooden one to get all the features on it? Because as I said before, with the 3D printing software, you can jump on, adapt one measurement, reprint the piece, and do something while that's printing. It's taken you a few minutes rather than adapting a wooden one each time, which, don't get me wrong, is enjoyable, but after the 3rd or 4th iteration can get a little bit tedious and time consuming. And that's tool number 4. As I said at the start, I was skeptical about how 3D printing fitted into woodworking, and how I was genuinely worried that being a tech dummy would really derail my learning process. And don't get me wrong, I'm not yet combining wood and 3D printing together for builds yet. I'm not setting the world alight with my designs, but for jigs and tools from brain to reality, 3D printing is just really hard to ignore in any woodworking workflow. But I will say, the choice you make for the printer itself, who to buy it from, and the design software you use can have a huge difference in your experience. I am the least capable with this kind of thing, and I found the Bambu Lab setup to get from box to boat was flawless. And then having Maker World full of ready-to-go prints at your fingertips available to you is priceless. Tie that in with makers on YouTube like Pierre the Swedish maker showing you the true capability of these machines means that now I'm convinced that anybody can benefit from a tool like this. And with the range that Bambu Lab offers, differing budgets are accommodated too. And don't forget there's a link in the description for the exact printer I've been using for these builds if you want to check it out for yourself. I feel like I'm just scratching the surface, and I look forward to sharing what I make with you. If you want to see it first and add your input, head over to Patreon and sign up. There's paid and free levels, the links are all in the description below. Speaking of which, the after show to this video has just been released and is live on there now. Thank you for watching the start of my journey with this. If you head over to Patreon or you click one of these, I'll see you over there.